Hello students. So today we're going to be talking about igneous rocks. Igneous rocks refers to the chapter in your book, chapter 2, lesson 3, and the learning target is I can classify igneous rocks by grain size, texture, formation, and mineral content. Now these things might not be super obvious right now, but by the end of this hopefully you'll have a better understanding and you will be able to come up with the simple classification that we use in class, which basically comes down to two different ways and they're kind of connected. So let's get into it. Make sure that you've got the learning target written at the top margin of your page and that you are, as usual, as always, lining up your page so that you have your normal Cornell style line at the top margin, line right going down the side, and the notes are going to be starting on that left side. Okay? So this is a picture of the Mexican volcano Paracutin. I always like Paracutin because I like the story behind it, that it actually just started erupting. The volcano formed from nothing, essentially, inside of a man's cornfield in Mexico. And he, I ended up having to leave. It ended up taking up part of the town. And it just, I like the story because I just like how unpredictable and how uncaring nature can be sometimes, that it doesn't really care that you have a farm and a city in a place. They're going to do what they want. And I like that it kind of is a great example, a recent example of how volcanoes form where they want and they form in specific locations. So more on that later. Now, we got to talk about magma and lava before we get into igneous rock. Igneous rock is rock that comes from magma or lava. That's basically it. That's your basic definition. Without magma or lava, you're not going to form that cooled rock. Once it cools down and hardens, it turns into it. So let's get a definition of magma and lava, because a lot of people use those terms interchangeably. Magma would be the liquid rock that is below the Earth's surface, and lava is a liquid rock that is above the Earth's surface. So a question that I sometimes ask is, was lava magma, or did lava used to be magma? And the answer would be yes. Magma, once it's lava, it can't be magma again because it's already started to kind of go on the surface. It's already started to cool down and lose some of that energy. But while it's underground, it's magma. After that, it's going to be lava. All right, next. Please get this header. This is important that you have this as a top line header. So just take this right here. You've got two types of igneous rocks. Now this should just be at the top, right underneath what you wrote for lava and magma. Make sure that you have this written, and then this following points will come as one bullet point under here, one bullet point under here. And these are going to be these things, but let's hold off on that right now. First, we're going to start with intrusive rock. I want you to write this as I have it written. So you've got intrusive rock, and you have right here, in equals inside. This is important because that's something to remember, okay? Intrusive rock forms inside the Earth. So I have written right here, cools slowly beneath the Earth's surface. Because it's insulated by the surrounding rock of the crust, it's going to cool a lot slower, like when you're under a lot of blankets, or if you put water, hot water inside of a nice, good thermos, it's going to keep that water hot for a longer period. If it's just spilled out on the countertop, it's going to cool instantly, very fast. And because it cools slowly, those crystals inside, those minerals inside of the rock, inside of the magma, as they cool slowly, they have time to kind of bunch up with light crystals. So something that has a very high melting point, that's as soon as it starts to drop a little bit, those things will crystallize out. And as it starts going through those, the like minerals are going to crystallize together. So they form these larger crystals. You're going to see rocks maybe like granite. Granite has large crystals. That's why people like it for countertops, because it has pretty colors and lots of different big crystals. In this picture I have here, this is of an intrusive rock that has actually been pushed up to the surface. And when you have this rock that's pushed up to the surface, you can see that all that pressure, the pressure on it that used to be under, has been relieved, and it starts pushing outward. It starts flaking off. And this flaking off is called exfoliation, kind of like what happens when you pull the dead skin cells off of your skin. Next, extrusive rock. Get this once again, X like exit. So you've got extrusive rock, exits the crust, exits the earth in a way. And so right here you've got the first point says cools fast above the Earth's surface. And exposed to the elements, it cools very quickly. So it's on the surface. It's, there's air there, there's rain, there's wind, There's all sorts of stuff. I mean, some of it just falls right into the ocean, but what's going to happen is because it's on the surface, because it's exposed, because the heat can just radiate out into space, you're going to have smaller crystals. It cools very, very quickly. There's no insulation from the crust. Even if you pile the layers of lava right on top of each other, it's going to cool pretty quickly. Okay, so right here, get this down as a header. Mineral composition or content. Right now, these are actually going to be, these down here, high silica, low silica, and SiO2, those are going to be written down as bullet points, but just get this top part, mineral composition or content, as a header. Now, next up, silica. What's silica? You guys might have seen those little packets of gel in shoes. It's a silica gel. Silica is a chemical that we find in different minerals. So quartz and mica, that little flaky stuff in quartz crystals, those are pure silica. Okay, silica is in a lot of things though. So silica is usually white, but it can have different colors. And silica is going to make things act a certain way or look a certain way. So right here we've got higher silica rocks. When a rock has more silica in it, it's going to be lighter in color. It's going to be less dense. So a good example of a rock that has a lot of silica is this picture of granite right here. You can see it's got those light colors. There's a lot of white in there. And we're going to talk about rocks as being less dense. That doesn't mean that they're not dense at all. I mean, rocks are still rocks. But compared to a lower silica rock like this, you've actually got lower density. So it's going to be lighter in a sense. Low silica rocks, get that down. And then under that even, make sure you've got darker color, denser, and a good example, the one I always like to use is basalt. So basalt right here, this is a nice example of basalt. It's dark, it's very dense, it's just kind of it's a kind of an ugly looking rock, but basalt is cool because whenever you find basalt, you know that used to be kind of part of a volcano. The lava came out of the land, it cooled very quickly, and that's where it came from. Anytime you see basalt, that is where it came from. It's a guarantee. So when I have rock in my hand from Taylor's Falls and I can see those samples, I know that used to be lava. So the last thing that I'm going to have you guys do is think about a couple questions. So this first question right here, what determines the grain or crystal size in an igneous rock? Is it the cooling speed or where it forms? And the last question is, are those options, both of those, cooling speed and where it forms, are they related? The last questions I have for you, I have 3 rocks, I have a ruler. The question is, which one cooled fastest, which one cooled slowest? Now, if we're asking about that, you need to have a basic understanding of the definition of what we decide is large or small grain. And the definition is anything larger than 1 millimeter equals large. Anything smaller than 1 millimeter equals small. So make sure you have that in there. Hopefully you can decide now which one of these cooled fastest, which one of these cooled slowest. Look at the ruler, look at the grain size. I will tell you that one of these is basalt, one of these is granite, and one of these is obsidian, volcanic glass. So try to figure it out. If you're confused about how to answer that, that might be something to write down to talk to me later. Hope this made sense. Hope this helped. Good luck.